Imagine a newborn baby. They've just been delivered. The umbilical cord is clamped, but there's a massive problem.
Right, a terrifying one.
Yeah, exactly. Their nasal passages are completely blocked by a solid wall of bone. They're turning blue, just desperately trying to pull in oxygen.
And the only thing that saves their life in that exact terrifying moment is throwing a screaming, thrashing fit.
Which, I mean, it sounds completely backward, right? If your airway is blocked, exerting energy by screaming, it should deplete your oxygen even
It
faster.
really should. It defies basic logic.
Yeah, I hit a complete paradox when I was looking at our source material for today, but we are going to explain exactly how a newborn screaming fit actually bypasses that bone blockage and, saves their life.
It's an incredible mechanism.
It really is. So for you, the curious learner joining us on this deep dive today, we are unpacking the incredibly delicate biological transition an infant makes from the womb to the outside world.
And more specifically, we're looking at what happens when that transition goes totally off script.
Right. We've got a mountain of notes drawn from Christy W. Sawyer's comprehensive medical text on neonatal hemolytic disorders and congenital anomalies.
And our goal here is to really dive into the mechanisms behind these conditions, not just the surface level, but the why.
Exactly. The mission today is to unpack the microscopic battles happening in a newborn's blood, the structural blueprint anomalies that alter how a body is laid out, and the hidden metabolic errors you can't even see.
Because understanding these conditions isn't just for medical professionals.
No, not at all. It's really a masterclass in human biology. It shows us exactly how our bodies are built, step by step, and how life-saving interventions step in when a biological blueprint skips a line.
It's fascinating how much has to go exactly right.
It really is. Okay, let's unpack this, and I think we should start with an invisible battlefield.
That's a good place to start, because before a baby even takes that first breath, they can be facing a massive immunological conflict.
You're talking about hemolytic disease of the newborn.
Right. Exactly. It stems from blood incompatibilities between the mother and the fetus, most notably Rh incompatibility.
So let's visualize this for a second. Say you have a mother who is Rh negative. Her red blood cells don't have the Rh protein on their surface.
Right.
But the fetus inherited the Rh positive trait from the father. If those fetal blood cells cross the placenta into the mother's bloodstream, her immune system is basically like an overzealous nightclub bouncer. It sees those Rh proteins as alien invaders.
That's a perfect analogy. Her body immediately begins manufacturing antibodies specifically designed to hunt down and destroy anything carrying that Rh protein.
Which is terrifying for the fetus.
It is. And what's fascinating here is the specific weapon her body chooses. The maternal immune system uses a class of antibodies called IgG.
IgU, okay.
Yeah, and out of all the antibodies the human body makes, IgG is the only one small enough to physically cross the placenta.
Which, I mean, normally that's a brilliant evolutionary feature, right?
Mm-hmm.
The mother passes her own immunities to the baby, so the infant is born with a starter pack of defenses.
Exactly. But in this specific scenario, that evolutionary advantage becomes a weapon.
Oh, wow.
Yeah. Those tiny IgG antibodies cross the placenta, lock onto the fetal red blood cells, and actually signal the fetus's own spleen to destroy them.
So the baby's own body turns against its blood.
Essentially, yes.
Yeah.
The fetal red blood cells are lysing or, bursting open much faster than they can be produced.
And when you break down millions of red blood cells all at once, you get a massive wave of a byproduct called bilirubin.
Right. And the fetal liver is completely overwhelmed by that bilirubin.
Leading to extreme toxic jaundice.
Yes, exactly. So the fetus frantically tries to compensate for the lost blood cells. The liver actually stops doing its normal job of making essential proteins so it can divert all its energy into pumping out immature red blood cells.
Wait, it just abandons its other jobs?
Pretty much. And because the liver stops making proteins, the blood loses its osmotic pressure.
Meaning what, exactly?
Meaning the fluid literally stops holding together inside the veins and leaks out into the baby's tissues.
Oh my God, that leads to hydrops fatalis, right?
Yes. Marked by severe anemia, cardiac failure, and massive life-threatening fluid swelling throughout the fetus's body.
That sounds absolutely dire. But the interventions for this, they are pure sci-fi.
They really are. Doctors can monitor the mother's antibody titers, of course.
But they also use something called an MCA-PSV Doppler. They use ultrasound to look at the middle cerebral artery in the fetus's brain and measure the peak systolic velocity, which to me is just mind-boggling.
It is incredible. Think of the blood like a river. If a river is thick with mud and debris, it flows sluggishly.
Right.
But if it's mostly clear water, it rushes quickly. Because the fetus's blood has lost so many red blood cells to the antibody attack, the blood becomes thin and watery. It moves incredibly fast.
So by measuring how fast the blood is moving through the brain, doctors can calculate exactly how anemic the unborn baby is.
Exactly. And if the blood is moving too fast, they don't just sit and wait for birth.
No, they do an intrauterine blood transfusion. They guide a needle through the mother's abdomen into the uterus and infuse Rh-negative blood directly into the umbilical vein of a fetus the size of a melon.
I know. They are essentially doing an oil change on a moving engine.
That is just wild.
Oh.
And there's the RhoGAM shot, too, for prevention.
Right, but postnatally, if the baby is born with skyrocketing bilirubin levels, the danger shifts to the brain. Bilirubin can cross the blood-brain barrier and cause permanent neurological damage.
A condition called kernicterus.
Exactly.
And the primary treatment for that is phototherapy, putting the baby under those bright blue lights. But I want to clarify how that works, because it's not just a heat lamp sweating the jaundice out.
No, not at all. The mechanism is called photosommerization.
Photosommerization, okay.
Yeah, those specific blue-green light waves actually penetrate the baby's translucent skin and hit the bilirubin molecules trapped in the tissue.
And the light does what? Breaks it down.
Not exactly. The energy from the light physically twists the chemical shape of the bilirubin molecule. It alters its structure just enough that the bilirubin becomes water-soluble.
Oh, I see. Allowing the baby's kidneys to just flush it out in their urine.
Precisely.
From light waves bending molecules to swapping out the blood inside the womb, it's staggering.
Yeah.
And taking that idea of intervening before birth, we can sort of shift from the microscopic cells to the actual structural blueprints of the body.
Yeah. Fetal medicine has evolved to repair physical defects while the baby is still developing. Neural tube defects, or NTDs, are a prime candidate for this.
And the neural tube is the embryonic structure that eventually folds and zips shut to become the brain and spinal cord, right?
Right. But sometimes it just fails to close.
At the top of the tube, a failure to close results in anencephaly, where the major parts of the brain and skull never form, which the text notes is incompatible with life.
Very sadly, yes. And lower down the spine, a failure to close results in spina bifida.
Which I understand operates on a bit of a spectrum.
It does. The mildest form, occulta, might just be a hidden gap in the vertebrae marked by a dimple or a tuft of hair on the lower back.
But the most severe form is myelomeningocele.
Yes. That's where the spinal cord, the protective membranes, and the spinal fluid all bulge out through an opening in the baby's back.
Leaving it completely exposed to the amniotic fluid.
Which is a huge problem, because while amniotic fluid is essential for lung and limb development, as the pregnancy progresses, the fetus excretes waste into that fluid.
It becomes toxic.
Exactly. It becomes highly toxic to raw, exposed nerve tissue. The longer that spinal cord sits in the amniotic fluid, the more the nerves degrade, leading to paralysis and severe bowel or bladder dysfunction.
Wait, so if there's a hole in the baby's spine, they can operate before the baby's even born. Isn't that incredibly risky for both the mother and the fetus?
It is risky, but the landmark management of myelomeningocele study, or the MIMA-S trial, proved the risk is mathematically worth it.
Wow, really?
Yeah. By performing fetal surgery before 26 weeks, surgeons cover the exposed spinal cord, stopping the amniotic fluid from continually dissolving those nerves.
And the outcomes are better.
Much better. Babies who undergo this fetal surgery show significantly improved motor function and are far less likely to need brain shunts for fluid buildup later in life.
That is just brilliant. But the craziest part to me is that one of the most powerful preventative tools for neural tube defects is literally a vitamin you can buy at any grocery store.
Folic acid.
Folic acid.
Yeah, the mechanism behind folic acid is a masterclass in cellular biology. In the first 4 weeks of pregnancy, the embryo's cells are dividing at blinding speed to zip that neural tube shut.
Right, building the whole nervous system.
Exactly. And to divide, every single cell has to perfectly copy its DNA. Folic acid provides the chemical building blocks, specifically metal groups required for that DNA synthesis.
So if the mother's body is short on folic acid, the DNA assembly line stalls.
You got it. Cell division slows down, and the tube misses its critical window to zip shut. That's why 400 micrograms daily is the crucial preventative tool here.
It's basically an environmental key unlocking a complex genetic process. Oh, and the text also mentions a surprising nursing alert regarding these infants. They have a really high risk of latex allergies.
Yes, they do, because of the repeated surgeries and catheterizations they undergo early in life.
Wow. Okay, so When we talk about these structural formations, the most common anomaly is actually in the heart, right?
Yes, congenital heart defects, or CHDs, are incredibly prevalent, and the transition the heart makes at birth is just violent and beautiful.
Violent and beautiful. I like that.
Well, in the womb, the fetus isn't breathing air, so the blood largely bypasses the lungs through a special vessel called the ductus arteriosus.
But the second the baby takes its first breath, the sudden rush of oxygen and the dramatic shift in pressure inside the chest trigger that bypass vessel to physically clamp shut.
Right. The plumbing completely reroutes itself in a matter of seconds, so all blood now flows through the lungs.
And when that piping doesn't reroute properly, or if there are holes between the heart chambers, you get CHDs.
Exactly. And some are cyanotic, meaning deoxygenated blue blood is mixing with oxygenated red blood, and the baby physically turns blue.
But the text says other defects are completely acyanotic. The baby looks perfectly pink and healthy.
They do, but internally, their heart is working 3 times as hard to compensate for a hidden structural flaw.
Which is terrifying.
It is, and that's exactly why modern medicine relies on pulse oximetry screening. Before a baby leaves the hospital, a simple light sensor on their hand and foot measures the exact oxygen saturation in their blood.
Which catches the invisible defects before the infant crashes.
Precisely. Once the heart is pumping correctly and the brain is functioning, a baby's survival immediately hinges on 2 primal instincts.
Pulling in oxygen and swallowing food.
Yes. But what if the plumbing is hooked up wrong?
Which brings us right back to the paradox we started with. The baby with the bone blocking their nose.
Right, choanal To understand why a screaming fit saves them, we really have to look at the anatomy of a newborn.
Okay, let's look at it.
Infants are what we call obligate nose breathers for the first 4 to 6 weeks of life. Their larynx is positioned exceptionally high in their throat.
And that high larynx is a design feature, right? It allows a baby to latch onto a breast or a bottle, swallow milk, and breathe through their nose at the exact same time without choking.
Exactly. So their entire anatomical wiring tells them to keep their mouth closed and breathe through their nose.
But if their nasal passages are blocked by that bone, by choanal atresia, they will stubbornly try to pull air against that solid wall.
Yes. They turn blue and start suffocating.
Here's where it gets really interesting, because the text says that when these babies cry, their color actually improves and the distress is alleviated. That seems entirely backward. Doesn't crying usually mean a baby is in worse distress?
Normally, yes. But here, the hypoxia triggers a panic response. They start to cry. And to cry, they physically have to open their mouth. Oh, so the second their mouth opens to scream, oxygen floods into their lungs, completely bypassing the blocked nose.
Exactly. They pink right up.
But then they stop crying.
That's the terrifying cycle. They cry, they get oxygen, they calm down, they close their mouth, and they start suffocating all over again.
Man, that is intense.
Yeah.
And anomalies in the plumbing can happen further down the chest, too. Take congenital diaphragmatic hernia, or CDH.
Right. The diaphragm is the muscle separating the chest from the gut.
And if it doesn't close all the way during early development, it leaves a gaping hole.
Yes. And through that hole, the intestines, the stomach, and sometimes even the liver migrate up into the chest cavity while the fetus is still growing.
Into the chest, where the lungs are supposed to be.
Exactly. And lungs aren't just empty balloons. They are complex biological trees that need physical space to grow their branches.
So if the chest is packed full of intestines, the lung on that side gets completely crushed. It can't branch out.
It stunts the lung growth severely. When the baby is born, their chest looks barrel-shaped because it's stuffed with organs. And their belly is scaphoid, or sunken in, because it's virtually empty.
Right. And as soon as the baby starts crying and swallowing air, those misplaced intestines inflate, crushing the tiny, underdeveloped lungs even further.
That is just a mechanical nightmare. But eating becomes equally dangerous if the feeding tube itself is broken. Esophageal atresia and tracheoesophageal fistula, or TF, it's a terrible scenario.
It really is. The esophagus just doesn't connect to the stomach. It ends in a blind pouch, sort of like a cul-de-sac.
And to make matters worse, the fistula and abnormal tunnel often connects that lower esophagus directly to the trachea, the windpipe.
Right. So the baby swallows milk, it hits the cul-de-sac, and spills right back up the nose and mouth.
Or, if it goes down that abnormal tunnel, they're aspirating fluid directly into their lungs. The instinct to feed instantly causes choking and cyanosis.
It's immediate respiratory failure. We see a similar spatial crisis when the abdominal wall itself fails to close.
Right, moving from the inside out.
Exactly. Now we are moving from organs trapped in the chest to conditions that literally put the intestines on the outside of the body.
The two primary abdominal wall defects being omphalocele and gastroschisis.
Let's look at the mechanical differences between the two.
But the way I kind of break down the difference between the two is um, an omphalocele is like carrying your groceries in a translucent plastic bag.
Okay, I see where you're going.
The intestines are outside the body, but they are protected in a membranous sac right at the base of the umbilical cord. Whereas gastroschisis is like dropping your groceries directly onto the front lawn.
That's a very vivid analogy, but it's completely accurate. In gastroschisis, the bowel herniates through a hole in the muscle wall, and there is absolutely no protective covering.
So those intestines just float around in the amniotic fluid for months.
They do. And remember what we said earlier about amniotic fluid. It contains fetal urine.
Right, so it's highly caustic to exposed, delicate bowel tissue.
Extremely. The intestines become swollen, thickened, and incredibly inflamed. And after birth, the baby loses heat and water from those exposed organs at an alarming rate.
Which requires intense postnatal care, because surgeons can't just shove the swollen intestines back in and stitch up the hole, right?
No, they can't. The baby's abdominal cavity never had anything inside it, so it never stretched. It's physically too small to fit the organs.
Oh, what do they do?
The first step is placing the baby's torso in a clear plastic bowel bag to prevent heat and fluid loss.
Like a greenhouse effect.
Exactly. Then they use a mechanical fix called a silo. It's a clear silicone cylinder placed over the exposed intestines and suspended above the baby.
And gravity just does the work.
Gravity and gentle daily pressure from the surgical team. Over 7 to 10 days, they slowly squeeze the organs down.
Which gradually stretches the baby's abdominal cavity until there is finally enough room to close the skin.
That's right. And while we are talking about the gut, I have to drop a critical warning from the text about a volvulus.
Oh, the ultimate mechanical failure of the intestines.
Yes. If the intestines don't anchor properly to the abdominal wall during development, they can literally twist around themselves, strangling their own blood supply.
And the most glaring symptom of this, the massive red flag, is bilious green vomit.
Right. Emesis. Bile is produced in the liver and added to the digestive tract well past the stomach.
So if a baby is vomiting dark green bile, it means the plumbing is entirely blocked further down the line and everything's backing up.
It is an absolute time-is-tissue medical emergency.
Wow. Okay, so the spatial constraints of the womb that contribute to issues like gastroschisis can also compress the developing limbs, right?
Yes. Moving to the musculoskeletal system, specifically developmental dysplasia of the hip, or DDH.
Think of a baby's hip joint like a ball of soft clay resting in a very shallow bowl. Because the bowl is so shallow, the ball can easily slip out of the socket.
That's the core issue in DDH.
Now, I've heard old wives' tales generations of parents saying you should double diaper a baby to keep their legs propped wide open and fix hip dysplasia. Is that real?
Not at all. The text strictly debunks this. Double diapering actually promotes hip extension.
Meaning it forces the legs to straighten out.
Yes, which levers the ball right out of the shallow socket. It actively interferes with proper joint development.
So what is the actual mechanical fix?
The real fix is the Pavlik harness. It's a system of straps that holds the infant's hips in a flexed, abducted position, knees pulled up and pushed out.
By holding that clay ball firmly centered in the bowl for weeks, the constant pressure triggers the body to carve out a deeper, more stable socket as the bones calcify and harden.
It's a purely physical solution to a physical problem.
We've talked about the blood, the organs, the bones. But what happens when the baby's physical structure looks absolutely perfect on the outside, but the microscopic metabolic engines inside the cells are missing a gear?
This brings us to inborn errors of metabolism, or IEMs. These are genetic disorders where the body is missing a specific enzyme required to process fuel.
And this is the entire reason the universal newborn heel prick test exists, isn't it?
Yes, it is. The value of that test is incredible. A few drops of blood on a filter card can identify these invisible errors before they cause irreversible damage.
Fetal canonuria, or PKU, is a classic example from the test.
Right. With PKU, the baby is missing the enzyme needed to break down phenylalanine, which is an amino acid found in all dietary protein.
So if a baby with PKU drinks normal milk, that phenylalanine just builds up in the blood.
And amino acids use specific gates to cross the blood-brain barrier. Phenylalanine floods those gates, physically blocking other vital nutrients from getting into the brain.
It essentially starves the developing brain, causing profound severe brain damage and seizures.
Unless the baby is put on a strict, specialized diet. The baby needs a highly specific synthetic formula that provides all the protein building blocks except phenylalanine.
So what does this all mean? It means we can use a highly specific environmental, fixally a strict diet, to entirely bypass a genetic dead end,
Exactly. We see this with galactosemia, too.
where the baby is missing the enzyme to convert galactose into usable glucose.
Right. And galactose is a byproduct of lactose.
Which means breast milk, which is loaded with lactose, is practically poison to them. It causes rapid liver failure.
So the fix there means absolutely no breast milk. They require a strict switch to a soy-based, lactose-free formula.
Or consider congenital hypothyroidism. The thyroid gland fails to produce thyroxine, a hormone absolutely critical for brain growth.
And again, if you catch it on the heel prick test, the fix is direct.
You give the baby a daily oral dose of synthetic levothyroxine. You just manually add the missing gear, and the baby's brain develops perfectly, preventing severe intellectual disability.
It's amazing. But this concept of missing gears gets profoundly complex when the anomaly touches on the core of physical identity.
You're talking about disorders of sex development, or DSDs.
Yes, DSDs occur when there is a discrepancy between the external genitalia and the internal chromosomal sex.
So a baby might be born with ambiguous genitalia, meaning you cannot visually determine their sex.
Exactly. And the text advises parents to delay assigning a gender until comprehensive chromosomal and hormonal testing is done.
Because the medical priority here isn't cosmetic, it's metabolic.
Right. Providers immediately test for congenital adrenal hyperplasia, or CAH.
CAH is basically a mechanical glitch in the adrenal glands. The glands are trying to make cortisol, a stress hormone, but they are missing the enzyme to finish the recipe.
And because they can't make cortisol, the brain keeps screaming at the adrenal glands to work harder. The glands get stuck in an overdrive loop.
They pump out massive amounts of intermediate hormones, specifically androgens, which causes the ambiguous genitalia in female infants.
But more critically, this broken assembly line also stops the production of aldosterone, the hormone that tells the kidneys to hold on to sodium.
Which sounds dangerous.
It's fatal if untreated. Without aldosterone, the baby's kidneys just dump all their salt into the urine. This leads to a severe, rapidly fatal salt-wasting crisis.
So you have to stabilize that life-threatening electrolyte crash first, and only then can the genetic and hormonal testing guide the psychological and medical care for the family.
Exactly. Safety first, always.
The sheer complexity of fetal development is just mind-boggling to me. When you look at the thousands of biological dominoes that have to fall perfectly, from the immune system standing down to the spinal cord zipping shut, the ductus arteriosus clamping, the gut rotating, and the enzymes firing up, it's an absolute miracle it works as often as it does.
It really is. And when things go wrong, it takes an army of interprofessional healthcare specialists to correct the dominoes.
You have surgeons, geneticists mapping metabolic pathways, dietitians formulating PKU diets.
And the incredibly observant nurses, we can't forget them. They often catch these anomalies just by noticing a missing wet diaper or an odd skin fold. They are vital.
Truly. And for you, the listener, it's vital to remember that these aren't just textbook clinical case studies of human biology.
No, they are monumental, world-shattering emotional crises for the parents living through them.
Exactly. Those families need immense empathy, anticipatory guidance, and support groups to navigate a reality they never could have prepared for.
Healing the anatomy is only half the battle. The other half is helping the family survive the trauma of the transition.
We often look at birth as the finish line of a pregnancy. 9 months of waiting and boom, you cross the tape. But considering how many metabolic, structural, and immunological systems have to seamlessly activate the literal second a baby takes its first breath, maybe birth isn't the finish line at all.
It's just the moment the environment radically changes and the machinery is forced to prove it can run on its own.
Exactly. It's just the most dangerous, complex pit stop in human development. It makes you wonder if clamping the umbilical cord triggers the heart to rewire its own plumbing and the lungs to suddenly inflate. What other hidden biological switches flipped on the exact day you were born that we haven't even discovered yet?